story to tell. The post-World War II jet engine era led to a series of high-performance designs at extremely high altitudes, allowing them to fly through most defenses. For example, English electric camera. Its large wings gave it the lift needed to operate at very high altitudes, placing it above the range where even jet-powered fighters hardly reach. The Canberra could simply fly over its enemy with relative impunity, a quality that made it naturally suited to aerial reconnaissance missions. This approach was extremely effective until the late 1950s, when the Soviet Union began to introduce its first surface-to-air missiles, which had speed and altitude performance much greater than any contemporary aircraft. The Canberra and other high-altitude aircraft, like the British V-bombers or United States Boeing B-52 Stratofrogers, were extremely vulnerable to these weapons. The solution offered was to fly lower. Because the radar operates in line of sight, the curvature of Earth renders low-flying aircraft invisible beyond a certain range, the radar horizon. This led to the birth of the TSR-2 project, a reconnaissance and attack aircraft developed by the British Aircraft Corporation for the Royal Air Force. Design work began in 1958, and the project was approved in 1959. TRS-2 made its maiden flight on September 27, 1964. The designers adopted the latest advances in swept-wing technology, with a small shoulder-mounted delta wing with downturn tips, an all-moving swept tailplane, and a large all-moving fin. Tubular fuselage with a raised spine behind the two-seat cockpit. The air intakes were well fitted behind the cockpit. The undercarriage was a traditional landing gear system with a two-wheel nose leg and two twin-wheeled main legs. Other parameters of the TSR-2 include length of 89 feet, wingspan of 37 feet 2 inch, height of 23 feet 9 inch, empty weight of 54,750 pounds. Maximum takeoff weight is 103,500 pounds. In terms of armament, the TSR-2 was designed with a total weapon load of 10,000 pounds, 6,000 pounds inside and 4,000 pounds outside. At the heart of the TSR-2 were two Bristol Siddeley Olympus Mark 320 afterburning turbojet engines, with 22,000 pounds of dry thrust each and 30,610 pounds with afterburner. The aircraft could reach a top speed of Mach 2.15 at 40,000 feet and Mach 1.1 at sea level, had a range of 2,500 nautical miles, a surface ceiling of 40,000 feet, and a rate of climb of 15,000 feet per minute. The aircraft featured some extremely sophisticated avionics for navigation and mission delivery, which could also prove to be one of the reasons for the spiraling cost of the project. Some features, such as forward-looking radar and side-looking radar for navigational fixing, only became commonplace on military aircraft years later. These features allowed for an innovative autopilot system, which, in turn, enabled long-distance terrain-following sorties, as crew workload and pilot input had been greatly reduced. Although the TSR-2 proved itself enough to be a successful design, the growing cost and controversy between the services over Britain's future defense needs, which together led to the controversial decision in 1965 to scrap the program. It was decided to order an adapted version of the General Dynamics F-111 instead, but that decision was later rescinded as costs and development times increased. It was later replaced by the American McDonnell Douglas F-4 Phantom II and the Blackburn Buccaneer. Panavia Tornado eventually was developed and adopted by a European consortium to fulfill broadly similar requirements to the TSR-2. My video about the TSR-2 answer. Thank you for watching. If you find this video interesting, please give me your thumbs up. Don't forget to subscribe to support the channel. Goodbye and see you again in the next videos. Tạm biệt và hẹn gặp lại quý vị và các bạn trong các video tiếp theo.